Hello.
Good morning.
Good morning.
Still
Morning,
need to
Hussain.
release the hounds,
Oh, yeah.
but I'm here.
Yeah.
Hey, good morning, guys.
Morning. How are you?
I'm fine, thanks.
It's great. I don't know. I know Amanda won't be here, and we may have Jesse might be here, but I don't know. So yeah. How is everyone doing? You good?
Yep, good.
That's great.
That's to report.
So yeah, we had one or two meetings this week. We had the DevoWorm meeting, which was pretty good. We had some good features in that meeting. We also had the cybernetics meeting, where we finished up the paper we've been working on. I think it's called relevance realization, and we just kind of tied up loose ends on that. So next time, I'm not sure what we'll be reading. I think we kind of decided on a paper, but we'll see how that goes. Yeah. And so I don't know if we want to do updates now or I can wait until we get more people. I don't know if Hussein had an update. I haven't seen him in a while.
Yeah. I mean, so once again, just on and off with various things here and there. So yeah, I began working with Dick under Richard Gordon. So we are examining these X-ray tracing for polycapillary optics used for breast cancer diagnosis. This should be able to basically replace like mammograms if we can get this technology together. And yeah, we can see how efficient and effective it is, and in some ways definitely more cost effective. And yeah, it takes a lot of we need to see if the simulations work. So yeah.
Yeah, it sounds great.
Still trying to get on board with OpenWorm and DevoWorm to make open source contributions.
Yeah.
And see where things go off. Yeah, sorry, didn't mean to interrupt you. Go ahead.
That's fine. No, I'm interested to hear.
Okay. Yeah. So excuse me. Just working on several different projects. Just to be clear. Yeah. First off, under Dick Gordon, we're using simulation technologies. So not just like MATLAB for 2D things, but we're taking advantage of 3D with Blender, Unity, possibly even Maya. But we should be able to do what we can do with Blender, Unity, and Unreal. For simulating the trajectory of X-rays as they interfere or as they interact with these different sort of hemispheres and chemical textures, as they can be applied to polycapillary optics used in breast cancer screening. So this is based off of a problem that has been formulated for the past several decades, and or it was formulated several decades ago, but no one has particularly looked into it. So if you're not familiar, Richard Gordon is a theoretical biologist with a background in chemical physics, and he's just been very, very, very sweeping and instrumental across many different disciplines, and he's quite the character. He's just really fun. He's just really fun to talk to. That's all. Like I'm getting the sense that he kind of is just like, he's so accomplished that at this point he can kind of just like do whatever he wants. And he's like, hey, you saying, do you want to work on something? And I'm like, sure. And you can just give me anything. And it's just really, really great. Ultimately, we'll see where this heads. It could lead to a manuscript. It could lead to being published, or even if it's just working on, say, like software, like technology. Those are obviously extremely beneficial too. So yeah, in other news, I'm also still trying to get on board with OpenWorm and DevoWorm software too, to see how I can contribute more specifically to simulation technology, even if it's just like dealing with issues, bug fixes. Those were always very helpful. But yeah, I do have the technology now to do so. Just really busy with other things because I'm still devoting maybe like 20 to 40 hours a week to the consultant position I'm working at the startup. That's through Ultra Learning, the educational technology startup. So yeah, Yeah, we have funding, and we've confirmed our own stocks and shares in the company. So, but ultimately, that's more so on a personal level. It's more so like investing in it for the future. We're not in the state where we can convert that to liquid, like to income. But more importantly, it's meant to be like you hold on to it, and then it'll be much, 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 much more in the future. So once again, this is a VR STEAM educational technology startup where we reach out to high schools and integrate virtual reality into the curriculum. And this has the power to be like, say, a multi-million-dollar industry if it a multi-million-dollar company if things take off. So, yep. Yeah.
That's good. That's great. Thank you. Yeah, I don't know if you had any questions about the OpenWorm or DevoWorm onboarding. I know you had presented in DevoWorm a couple weeks ago this open and closed worm repo, and I didn't know if you had any questions about that or
Yeah, I'm
any.
still getting some of the things together. Ultimately, there's definitely a lot to do. A lot of if you just have the data and the software together, there are definitely many things I can sit down and do myself. So I would appreciate just maybe further direction in terms of what might be most useful. I know Bradley and I did previously discuss, say, I pitched a few ideas to Bradley, and and maybe I showed it to a few others, and I think you had mentioned. Let me just scroll back through Slack and see if I got this right. Excuse me. I pitched a few ideas about the getting on board with OpenWorm and DevoWorm, and yeah, right. Data, we had mentioned two different ideas that seemed, or rather one idea that seemed really really useful. Convolutional neural networks to process microscopy images of C. elegans and identifying development features. And perhaps recurrent neural networks, RNNs, for capturing temporal dependencies in sequential data. So, yeah, yeah. More on, say, the data fusion and data analysis and data integration side of things. So, yeah.
Yeah, I don't know if I could say what would be most useful because it's like there's so many things that could be done. It's like, but I think something like that. Just kind of coming up with your own like interests, using the tools and putting them together. That would be perfectly good.
Okay. Yeah.
Yeah. Usually, we try to. Well, one way to do it, of course, is to contribute to the code base, but then another way is to like actually fork it and do your own thing. And I think there needs to be more of that because people. I don't know if people are not. I know it's hard to. I see people talk about it, and it's uh, like that. There's some magic that's coming out of an organization, and I mean, it's not magic. It's just kind of software, and so
Yep.
you just use it the way you want to, and that's pretty useful.
Yeah. I mean, everything is really easy to set up and to get into. By the way, like everything is seems pretty documented pretty well, which is surprising from an academic point of view.
Yeah.
I'm sorry. When I worked in bioinformatics, I swear 80 to 90% of my time was just technical stuff, like installing. I felt like if you're working in bioinformatics, you're basically working in IT, like while you're doing it. But yeah. Anyway, speaking of which, I've also obtained certifications in AWS through Amazon Web Services, including some of them that are more relevant to science, would be like the AWS services for machine learning, AI and machine learning. So basically, Amazon Web Services offers their tools and computing platforms and capabilities that people can use. Primarily they think about it for like businesses, for products, but it's used in science and scientific research too. So let's say I need to say like analyzing data using some of the AI or ML technologies through AWS. That might be useful. And it just has so much potential for high-end, high-level infrastructure. So if there's something that's meant to be like public source, open source, involving user interface collecting data, AWS definitely offers that to be done well. So, yep, yeah, okay. Thanks.
Oh, good. Yeah, thank you. That sounds great. And yeah, there's a lot to talk about there in terms of open source and infrastructure, and it's not just limited to Hussein. Anyone can pick up on this conversation. We're going to start our open source meeting soon, so we'll be talking maybe more about some of these issues in more detail. But it's always good to think and revisit those things.
Yeah, thanks. Well, in completely unrelated news, okay, this is a secret. Sorry, not really. You don't need to tell anybody because it's not. I'm not gonna sharing this isn't gonna really affect anything. But one of my friends who finished up his PhD in statistics, he's a very very accomplished, very very intelligent guy. He might have solved one of the Millennium Prize problems.
Oh wow.
Okay. I can't really say much about this. I do have to keep some of it on the down low for sure. But he's not just like some crackpot who like read a math book one day and smoked a blunt and now he thinks he solved P equals NP. No, he this is pretty legitimate. But yeah, so that's some exciting stuff, and he's been telling me about it. He wants to start a quantum computing software startup.
Wow.
Based off of his findings, if he can get it together. So that could be what accelerates. It's for the P equals NP problem.
Okay. Yeah.
He might have solved it. Okay. And I have to just be very, very careful here because I don't want you guys to go out and say that Hussein found someone who found the solution. Like, please don't do that. Please don't do that. Okay. That's why I'm just being careful here.
Yeah.
And plus, people who say these things, they get targeted. They can get targeted, and they have to be very careful with how they formulate it. And obviously the community is going to put it under deep scrutiny before anybody says anything. So, but that is very exciting. That's so cool. Obviously, yeah.
Yeah. So, any other updates?
Some meetings this week. One thing for sure, just related to AWS, that I see, like the NeuroDesk developer reposted something from AWS for nonprofits. That I don't know if this has always been the case, but there are credits to be had for nonprofits, and NeuroDesk is a project. Stephen Bowman down in Queensland. I forget which university it's at, but it's always been a great project where they can use credits in the back end and kind of seamlessly give you the compute resources with all this great containerization that they've got. So for I think I've asked you before if Orthogonal was a registered nonprofit or not, and it relates to the Anyway, we're going through the process with this restructuring in our TechX, and Celsius, the community biolab here, just got its incorporation done, and I think we're waiting for the final approval from IRS on the nonprofit status. But it just good to point out that there are these resources available, and AWS isn't the only one too. Like I think NeuroDesk was originally using Oracle, and Oracle Cloud Services was in trying to compete. This is why competition is good. That they were giving away a lot of free credits. Anyway, the week started with meeting, the FNIRS meeting, and talking about how to do cognitive loads. Again, like this is sort of neurotech focused. and but it was interesting because some of the tech people that come to this particular conscious tech collective meeting, definitely a lot of programmers, designers, etc. But some people who connected with the Hume AI group, which is trying to bring emotion and these other human I would call human traits into AI, and the difficulty of yes, Jesse, yeah. If I didn't put that in the Slack, I will. Yeah. That's a weekly meeting here in San Francisco. So yeah, happy to put a link. So that was a great meeting. I think there'll be some good follow up from there. Yeah, excuse me. And then Wednesday was the neurospatial AI meeting. So this is the organized by the OpenBCI principals, and their new product is the Glia headset. So this is a VR combined BCI, which is EEG, device. So OpenBCI is an open source hardware EEG maker system, in that you get access to the hardware, you get a kind of single board computer like amplifier, and in this case they're using dry electrodes, and it was a great the OpenBCI principles have been around long enough that they call a meeting. It was great to there was people doing consumer kind of FNIR stuff to people who'd been at BlackRock, which is an implant company, so that was really interesting, and yeah, a lot of great connections made there. Some of that was also related to the space that we were in, is something that we're looking at for the community biolab at this point, and we'll be this is San Francisco centric, but we'll be announcing MIT puts together a course materials for something called How to Grow Almost Anything, and it's a synthetic biology course. So we'll be announcing the start of that pretty soon. And this looks like one of the potential locations that we're going to be doing that. So that was doubly interesting to meet the people who operate that building. And then Thursday, Foresight and I think what they call pathways, and Foresight together with another group that seems to be somewhat like a future humanity like group, in if you know that group in Oxford. But the focus was neurotech. So people talking about connectomics. It was great to have Max Huddock there from Science, this new spin-off or new company after Neuralink that seems to be focused on biohybrid implants, and yeah, just a bunch of people kind of somewhat speculating, grounded in kind of deep tech about future neurotech advancements. So that was pretty interesting, and again, just nice to meet some people in person that I've only seen in YouTube videos. And yeah, and and then follow-up meetings with some of those people yesterday, talking about the Ed Boyden and others work at Picower on Alzheimer's and related dementias treatment with 40 hertz entrainment or 40 hertz stimulation, and discussing some of the devices that you can use for that currently with humans, as well as my particular interest, which was like, can we physiologically understand what's happening with this? And it seems to be related to the lymphatic system. That's something that has only recently been discussed as being well understood as a system, and ways to monitor that non-invasively with MRI, as well as stimulate it with both audio-visual stimulation and potentially focus ultrasound or transcranial interference stimulation. So a lot of neurotech there, I must say. So apologies, I didn't make this cybernetics meeting because basically somebody at the neurospatial AI meeting told me about the foresight meeting the next day. So I wanted to jump on that, and I've never been to a foresight meeting before. I don't know if Jesse has, but anyway, it was. I don't know what's that. Yeah, definitely some interesting things. I haven't dug into the. I still need to go release the hounds. I haven't dug into the some of the interesting papers this week, but definitely some good online meetings too that we should check out. And I was hoping that I forget her name, Paola.
Yeah.
I was hoping to hear about, so Combined Harmony was this week. European Brain Stimulation meeting was this week. And Maxwell Biosystems, kind of a 2D, 3D stem cell organoid company conference was this week. That remember Katerina that we talked to from UCSC?
Yeah.
Yeah. So she's done videos for Maxwell Biosystems talking about the organoid work that they do and brain engineers.
Okay.
So, and a great Celsius meeting in the new space, and anyway, we're going to be having a meeting on Sunday talking about cerebral organoids in particular. So it's been great through Celsius. I've gotten to meet people who've worked at these because I knew San Francisco, especially South San Francisco, where the big biotech companies are. I know there've been cerebral organoid companies, startups that have been doing various things. Some medical, some not. Some are more like cortical labs. So it's been great to meet people from those companies. A lot of them have started and already kind of lost funding or didn't meet targets or something like that. But still, there's a lot of experience here and a lot of interest in trying to put something together and in a more open science way. So really excited to have a meeting on that on Sunday.
Well, that's great. Yeah, thanks for the update. That's a lot of activity this week. Sounds like you were really.
it was, like all very neurotech,
right?
But it's still good.
Yeah. Yeah, we had some things.
Sorry, related to that, like the implant companies in particular are making a real PR push. So everybody's trying to get announcements out about progress that they're making.
Oh, wow.
And so so sorry, a lot of this I post in NeuroTechX's Slack, but it's like, there's new stuff from Synchron, there's new stuff from Neuralink. BlackRock is doing something on the 23rd, doing a online event, and like I think it's motif neuroscience has new focused ultrasound stuff that's finally published, and really exciting time in the what I would call implant orientative neurotech scene.
Yeah, sounds great. Yeah. So we had a bunch of things in the chat here. Let's see. I don't know where we start here. It's a secret to everyone, as the saying goes. Jesse said, "This is starting to feel like another meeting in another group. If we talk more about AWS versus Oracle, yeah, like, I imagine Jesse's other engagements where he's talked about these things." And then, is there a link to the Conscious Tech meeting? I guess we're going to put that in the Slack. I need to do more there, and also maybe this kind of VR learning Hussain mentioned. Yeah. And nice shirt. Say it online, but not to my face.
He has a Julia shirt. That's pretty cool.
Oh, okay. Yeah, the Julia shirt. Jesse, say it online, but not to my face. What was that in reference to?
I think it was just because it was me being weird and making a reference about like being able to do meetings or whatever, and it's just a funny remark about that basically. Also, I most of my comments were just rubbish remarks.
Okay. Yeah, April is here and a bunch of events are blazing through. It's always April and May. Yeah. So I don't know, Jesse, if you want to give an update.
I would really, I think I'm going to be able to finish my AI cures post, and I'll just go through that post a bit later. But I need like an out, like maybe 30-40 minutes just to do that, because it's I might go through that later on. I'm saying, and my general remarks, and I'll go over some of the things there are. I basically, it was I had like the tale of two Aprils so far. Because the first week was boom, 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 all sorts of stuff that I didn't even get to talk about yet. I didn't get to talk about hardly anything last meeting. I was rambling through stuff last Saturday, like, oh yeah, this like thing happened at AI Cures and all this stuff, and I didn't even have time to process it. And then unfortunately, as I was working on this ABM tutorial, I was working on writing this stuff up. Come Monday, I was out. I was it wasn't COVID. I was just a very severe flu, and and basically until yesterday or Thursday, like Thursday night was the most I talked like semi-intelligently and functionally all week, and that's saying something for that. So I've been out of commission. So I've been on like this very undesired pause since most of this week as my major update, which is really not fun because there's a bunch of things happening. I'm actually, today is also NYCWiC, and I'm not there, which is really disappointing, but I didn't know. I was worried if I was going to have COVID. It was like, I'm not going to go to this event, and I didn't want to travel while this is happening, and I had to go by myself, and I was just, it's really disappointing. However, NYCWiC looks great. It's the first year without the longtime captain, the main organizer. So I'm a co-chair. I didn't do a whole lot, frankly. I helped out. I did some administrative stuff. I did some things, but I was definitely a role player. but really, really, really proud of the team for doing it and for like kind of stepping into the brave new world after, when when the main person does it, he goes away. It's really hard sometimes, and frankly, a lot of things stop altogether. Really good things, like unfortunate examples, Princeton Vision, like that just between that and the pandemic, it just like got taken out. So, but yeah, really big. I might share some more things about that in the Slack, but it's doing well this year, and I'm really proud of all the people at NYCWiC, New York Celebration of Women in Computing, and shout out to all the co-chairs and the people who stepped up to make it happen. So cheering for everybody there. Also found a few really nice posts from people sharing their experience from last time. They posted on like LinkedIn, and I'm trying to aggregate them into, I don't know, a blog post, but just putting on the NYCWiC LinkedIn so people can see them. But it's a great event for like the community and for welcoming people into it. And I think it's the classic zone of like extremely high impact, and then extremely like it's so hard to high impact and low visibility, and it's tough. But people's doing a great job, so round of applause to them. And I'm sorry I can't be there. So that's NYCWiC. We didn't have any Kitchen Future meeting again, and it was the first time ever in existence of this didn't have 3 readings in a row outside of an unintentional break or something like that. So I look forward to going back to that. Yeah. The cybernetics reading group was good. I don't know if you want to say more about that later, Riley, or not. I can say a little bit now, but I just really like what we're doing with that, and I want to. Full disclosure, I'm really working on the design of working groups for what I'm doing with JoPro, and I'll explain more about that ahead. But I am really interested in doing like project-based learning and project-based like, I don't want to say research, but how certain things can be developed in terms of like what, I don't know, not outcomes, but like I think there's some major themes that are emerging from the overlap between, I guess, whatever is the cybernetics group and cognition futures. It's the lines are blurry. It doesn't really matter, but like there's this very interesting channel of discussion on memory. There's this very interesting channel of discussion that's kind of implicitly centered around like Michael Levin's work, and it's really nice because the last people we're reading, which is a huge criticism of, intended to be a huge criticism of Levin's work, and taking someone disagreeing with Levin and Sam Gershman and other people who are like basically associating computation as cognition, and Yogi Johannes is saying like, well, that's not at all possible, because computation or algorithms make things too much of a small worlds, finite environment, and that's trying to make something irreducible that isn't. That's what he's getting at, and it's nice to kind of see it was interesting because it sort of demarcates some of Levin's ideas, although it does and it doesn't, because a lot of our discussion and it was like, well, okay, well, what if we just like, what if you chose to talk about the word computation differently, and how that affects like what you're trying to do here. So it's sort of like it's a nice example because we've talked a lot about Levin, but also you're kind of seeing the camps of the different viewpoints and what sort of maybe semantic or like what's philosophically, I want to say valuable, but salient and doing work in the situations versus what are, what's sort of being addressed or not. I think it's a nice example of that because I think I don't think affinity is the correct word for this, but I think I respect polemic papers that are really trying to make hard demarcations. And I think I respect the papers and the argument process itself a lot more than people who are really hardcore, like, being a purist or an ideologue to them. Because I think the papers, in their harsh contrasts, at best, when they're doing really well, can help, almost do trace arrays or delineate stuff, and it doesn't mean they do a great, excuse me, I don't think it's a great way to approach the world or do a lot of work outside of them, but I feel like they're valuable in a very specific way. So I think it's been nice to see that from that paper, and I think it opens the door to return toward, okay, well, where's Levin going with this other stuff, and sort of we're kind of at this space concluding the paper. We didn't really get to spend a lot of time here, but I'm looking forward ahead of okay, let's really think about, I forget what Bradley said specifically about computation, but what is, what is computation? What can computation do here? What are the different definitions of it? How do we want to, what's a useful approach to this whole arena or not? And it's what the takes on computation that we're trying to consider. I think that's a very nice space. And it looks like you might want to say something about that. I think so.
We might. Yeah, I have a paper later, but we'll talk about that.
Okay. Excuse me, my throat's still. Sorry. Outside of that, so there's sort of memory stuff. I'm okay with just saying, yeah, a lot of what Michael Levin's doing is generally interesting to me in that space. And I'm not even a biology person outright. So I say that raising my hand is look, I'm not that, but a lot of the work he's doing on the spaces. I found a really amazing, he has an FAQ, academic FAQ post on his Thought Forms blog, which I think I posted that somewhere or not, but that's just amazing because it's he goes through, how do you feel about this? How do you feel about ethics? How do you feel about cognition? What about this part? He goes through a bunch of common questions. I was okay, I have to study this and mind this, not just because I think Levin's having a conversation with the gods of nature on the side and is distributing these tablets out to us in that sense, but it's more, I think he's got one of the better vantage points in the way that we talked about that with Norbert in the past. So I think his vantage points are very interesting from that sense. But we have 11 stuff, memory, computation, and we're I think we're looking at Rosen stuff next time, and anticipatory systems. We talked a little bit about that, and I'm very excited to go into that again too. There's this resurgence of, a very strong resurgence, and then nothing this week because of my other junk I'm dealing with on agent-based modeling and modeling other things in that simulation sense. And so I said in the chat, what do we have here? I guess I didn't say this specifically, but I'm interested in the VR stuff, but also I think I want to lean a bit more into sort of the simulation and modeling aspect of things a bit more, and maybe hopefully play around with things I'm learning in my actual degree program to that end. But to be continued there. So those are all sort of topical things that have been happening between the last sort of 2 weeks. And I guess the other update I have is I'm still hoping to get in, but I was waitlisted for the DISY Diverse Intelligence Summer Institute, which is the best. I've usually gotten nothing. So being waitlisted is a step up, and that's great. If I get in, there's a really high chance I'll go. I kind of want to go to. In one version of amazing fun summer stuff, I just go to Oxford at the start of May and then stay 2 or 3 months in Oxford area and go to Disney. I think that's pretty unlikely, but if I get into the summer school, I'll definitely try to go there. There's a few events, plot twist related events, and conferences and stuff that's been happening that they've been accepted to. The Inclusive Gaming Conference.
And these are events in Oxford?
What's that? Sorry.
What would be taking you to Oxford?
It's called the Inclusive Gaming Conference. It's like brand new. It's by the Internet Institute there.
Okay. Mm-hmm.
Plot Twisters has been accepted into it for what we're trying to build there. So that's cool. I think a few people will be going to that. I'm not sure if I'm going to go or not myself. But I want to. We'll see. What else? I might go over the AI cures thing a bit later. Oh, it's already 10:40. These are really a lot of updates today. Okay, I'll just say things are happening with Joe Pro as well. I mean, this it's the spring term has begun for me, so it's kind of back to that. But I'm continuing to sort out this the administrative junk of a lot of Joe Pro things, and I'm happy to do that. There's a few conferences ahead. Oh, last thing, I got an email this morning, or last night, I guess, from A-Life about I don't know if it's I think it's agent-based modeling workshop they're doing. So we're invited to submit to that. For some reason, I think I became the contact person from that. I don't know if you got it too, Bradley, but
I did not. Yeah,
every year it's from the same person who gets sent to me at like my old email. So I think I'm on just some weird list from that. But I'll post that. I'll share that. I'll forward that to us here.
Okay,
But I think it's a modeling workshop that looks cool. So yeah. That's it for me. There's other things, but I don't want to spend more time talking about it. Yeah.
Well, that's great. That's a lot of stuff there. I know some of it is like, the newer people might not know. It's just kind of like they don't know the acronyms and things. So the NYCWiC is the New York Celebration of Women in Computing, and we've been involved in that annually for the last couple of years. We didn't do anything this year, but
yeah,
Jesse
I took this year off from trying to organize stuff. Usually that's been through like Society Ethics Technology team, and it's been a great it's actually I actually just referenced them. Oh, actually, I referenced them explicitly in my data ethics and stuff course, because the course that I had the discussion with the instructor the first time is like, yeah, what I want to do is this is supposed to be a program where a lot of people from different backgrounds come to this online environment and different backgrounds. So it's to learn data science. So I want to get people the experience of communicating across different backgrounds and talking about technology and stuff. I was like, well, actually, yeah, that's kind of what I tried to do with this group, and I didn't say that directly, but I lightly touched upon it. And so the first discussion session was basically me, it was immediate high-level conversations about that process. And okay, I don't want to dominate the conversation about how hard it is to do that, why that's important. But it was really cool to see someone else in the field directly attempting to do the exact same approach and modeling that I've tried to do and that we've tried to do. And granted, I did it at the very simplest of levels with that group. But part of why NYCWiC was really cool is because we had social work, we've had psychology people, we had computer science and data. We've had a very diverse group of people just getting together and thinking about these problems. We would do these sort of collected group almost like a I don't know not quite a panel, but a series of just almost like different columns of a discussion, different people getting different experiences, but all thinking about it together as sort of this group of people making technology, people dealing with interfacing with technology. So that's not what NYCWiC is about per se. It's just what we've done at NYCWiC, and otherwise NYCWiC has been a really nice
venue
space to do that. And let's see. I think I'll just share. Yeah, I'll just share the page really quickly, just to talk about it because it's a really cool. I think this is gonna work. Oh, yeah.
Yeah.
Okay. So yeah, here's the main. I'll do it as a member view. But like, thank you for following. Hussein. But it's here. You can't see the post that we have. That's weird. This is a great story. It summarizes it pretty well. But this is someone from last year. Last year, this individual, Alicea, she had a great time. She connected with a keynote speaker. She's coming back this year to. She's I think she's presenting here this time as well. So we have a really nice like community of people that are really interested in being mentors and helping other folks come out and to their first conference and a lot of first time research talks, how to do a poster session and really give people sort of more tailored opportunities to grow and have sort of a nice experience and hopefully, give them a sense of community about it too. So yeah, it's nice that way.
Great. Yeah, I know we missed it this year, but it's good to see that things are going on, and we haven't revisited the Ethics in Tech Society Ethics in Tech project in a while, so I think it would be nice to maybe revisit it. We could do that over the summer if people are interested.
I think there will be some now that my illness, like I'll be fine. It'll totally disrupt my ability to speak. Excuse me. Yes, the course I'm in, I think will provide some interesting fodder because I really want to get to some of the rigorous like modeling or lenses or like what are they doing outside of just talking about it and being able people who like working in that space would be exciting. So more to come on that, I think.
Okay, yeah, great. Yeah, and we had some things in the chat. We had Hussein had to leave, so thank you for attending. Morgan actually has the link, or he posted the link to this here, which is the Conscious Tech Collective weekly. So this is a weekly meeting.
Yeah, that's a weekly meeting, and they are if anybody would like to present, they would like to see more. I also posted a link to an AI meeting with some historic figures.
Which one? This one here or in the Slack?
Yeah, the that event, right? This McClellan's going to be there.
All right. Yeah, McClellan keynote. Okay, so that's great. Yeah. And then new landscapes for AI research.
Yeah, if you hit the view full agenda, you see the keep going down. Yeah, I'm particularly interested in the challenges for AI in biomedicine, and the for developing AI.
Yeah.
But you got Ganguly there in that final panel,
right?
Among others. Definitely got lots of great people, and you can catch it virtually.
That's great. So this is you have to pay for it though. So yeah,
it is somebody's taken. I think the speakers might have been compensated.
Okay, well, yeah. Well, that's not a bad thing.
Yeah.
But...
So Jess, sorry, they seem to delete their meetings after the after the meeting is done. I don't know why. I will ask Ming why.
Oh, you mean the agenda or the?
Yeah, he
Yeah.
was just asking, do you have something that's not from, do you have anything from this year from Tech Collective? And I do not. Um, so I can give you the other meetings, the Foresight meeting and the Open BCI meeting.
Right. Yeah, that'd be good.
But the Conscious Tech Collective's meeting page is already deleted.
Oh, wow. Yeah, it was in October 3, 2023.
Yeah, that's just their landing page. Or sorry, was that Adama? Yeah,
Yeah.
sorry. That's the yeah. Take it up with Ming. I think she's listed there. Yeah.
Yeah.
So the Ming and Jacob are the two founders of that meeting, and these all, this and the Foresight meeting all seem to take place at these collective spaces. So it was the Foresight meeting was at Embassy, which again is kind of it's a very large house that's kind of shared ownership.
Yeah. That's great. Thanks for the links.
Yeah.
Yeah. So I don't know if Adama or Shubham wanted to share any updates. I know Adama said that she wanted to maybe present next week or.
Oh yes, actually I'm using my little brother computer.
Okay.
I don't have the diapositive I made because it is on my own computer.
Yeah. Yeah.
And I wonder if I can present my project next week.
Yeah.
Okay.
That'd be great.
Thank you very much.
Yeah. Yeah. Thank you, Adama. It would be great to see. So let's go to. I wanted to review our computational psychiatry Slack channel because I talked about it last week and I said we would do it, and then we did another channel. So okay, so we've got a lot of these things back up, and the reason we do these reviews is so that we can kind of bring some of these things to life. There are a lot of links in here, and they just kind of go off into the memory hole. So we can go through some of these papers maybe, and with commentary, it'd be great. Yeah, so one of the themes in computational psychiatry is where they're trying to use computational methods to get a better handle on psychiatry, and of course Morgan has a specific sort of vision for this, and it's not quite the same as the rest of the field. So this is why we have this space. One of the reasons why we have this space.
I was pleasantly pleasantly surprised by the NIH's computational psychiatry. I don't know if I would call him director, but this is someone, program manager or something, and he was using a much broader definition. So originally, computational psychiatry had and this perhaps just because there were so few people. So it very much began as application of neural networks and computational models applied to behavioral data. So and it's expanded to being the computational models perhaps having physiological relevance, and now with I think deep learning and it's becoming ubiquitous in all fields.
Yeah.
Has kind of changed, like in some way we've all become computational as deep learning comes in and feature engineering is automated for us, and and yeah, so you'll see a lot of perhaps psychiatric, general psychiatric work listed here, but I think it just reflects that computation is become central to almost everybody's research program.
Yeah. Yeah, I think
Yeah,
that.
but I definitely have an eye for things that might be of interest to Jesse in the DSM project.
Yeah.
and I've enjoyed some of the work. People who are tackling psychiatric problems are talking about fuzzy labels, and so as being treating psychiatry is an example of a machine learning problem, a general machine learning problem, but just where the labels that you have are perhaps not always appropriate.
Yeah.
Right. And you get lots of that from the kind of data that comes off the internet. So these are not unique. And it's interesting to see what general what mainstream deep learning and other computational modeling approaches would be useful in this context.
Yeah. Let's see. So yeah, let's go back to
also
the.
Having some.
Oh yeah. Let's go back.
It's been a brutal allergy week here in San Francisco.
Definitely. Yeah. So there, there's this one article from the bioRxiv, a data-driven latent variable approach to validating the research domain criteria framework. So this is RDOC, and I think this is something from the open science community where they did this research domain criterion framework, and it's used in psychiatry and neuroscience. Recent studies suggest that the RDOC is insufficiently specific or excessively broad relative to the underlying brain circuitry it seeks to elucidate. So this is what you're talking about. One of the things you were talking about.
This is even better. So this is even more aligned with my background, in the sense that this is like a neuroimaging specific paper, but it's so RDoC being the new framework that's driving NIMH evaluations of research and prioritization. And it's very transdiagnostic, but this is a paper where you might recognize a lot of people here. These are all big names in neuroimaging analysis. I would say. Mumford's well known for her tutorials on stats for people. Poldrack runs the Open Neuro and Center for Reproducible Neuroscience. Damien Fair, certainly in psychiatric neuroimaging, he's the new head of the Masonic Center for Developing Brain. And Manish Sagar, someone at Stanford who's multimodal but also computational, and so it does a lot of topological data analysis as well as full physiological models. So really integrating computational neuroscience together with neuroimaging.
Yeah.
So it's an all-star cast in this one.
Oh yeah, definitely.
And we'd sorry, I forget her first name, but Udin's paper, the metaphor, brain is paper we discussed, I think like a month or so ago.
Yeah, so it looks like they've done as a meta-analysis, taking a bunch of fMRI data sets and kind of going across them and looking for, a model that kind of describes some of these things. So external validation was performed with 36 peak coordinate activation maps from NeuroSim using terms of RDOC constructs as seeds for topic meta-analysis. Our results indicate that a bifactor model with a task general domain and splitting the cognitive systems domain into subdomains better fits the current corpus of TfMRI data than the current RDOC framework. So again, this is just these frameworks that we use in science and having finding the best one to describe the data. And this is, in this case, they're making the case for their approach over the standard approach.
But basing it off of, to some degree, physiology.
Oh yeah, definitely. And using different types of criterion, you can come up with different answers sometimes. And of course, physiology is, it's not necessarily always going to match, like a behavioral criterion.
Yeah.
So this is, there's some interesting things in here. This is prize learning temporal action abstractions as a sequence compression problem. So this is actually related to large language models and this approach called primitive sequence encoding that combines continuous action quantization with BPE, which is byte pair encoding, to learn powerful action abstractions. So this is just building better representations for large language models. This one here is this is scanning the new frontier of mental health, psychedelic brain imaging. This is more on this stuff, the psychedelic research that actually isn't Amanda involved in this. I think at the University of Michigan, she does work on something similar. Yeah. So this. Go ahead.
Yeah, this is someone very interested in pushing, more neuroimaging of drug interventions or drug challenges, we would call them, to make them. So
that goes through the use of Western use of psychedelics. Neuroimaging psychedelics. So there's this history of neuroimaging and psychedelics, and you can have like these brain connectivity maps that that show variation under psychedelic use. So, this kind of shows an example. The placebo is on the left, and then on the right is psilocybin. So this is where you get more connectivity essentially. And so they kind of walk through some of the future opportunities for research and all of that. So that's good. That's a nice article.
And since Matt is not here, let me say a few things that have come out of our discussions, which is, it's very easy to find differences when you dose people with psychedelics or other compounds like this, and like it's not surprising, but like the statistical properties of the time series are significantly altered. It becomes really important to be much clearer about what is your goal, and can you, to me, it's can you say something physiological about this, in terms of a better, these challenges are supposed to be revealing physiology and dynamics. And so, the scanning itself isn't as important to me as the computational models that you're using, and if you will, like the explainability, because we see, especially or there's a longer history of this with anesthesiology, where it's just like you're using nonlinear methods to find some difference, but that difference is it's very unclear how our knowledge of the physiology has been, updated, because we've found some, increased Lyapunov exponent, or
Yeah.
like yeah. So but yeah, Matthew Wall is someone who's definitely really interested and has been looking for more funding for this, in terms of I think he works at you see the affiliation. I think he's at, like in, I want to say like he works for a company. Oh no, okay.
Center for Psychedelics.
Yeah, in
Vicro.
Vicro. Yeah. Or yeah, that's the. I think they're kind of like a CRO.
Okay.
Yeah.
Yeah, that's great. So
But just to go back to prize there for a second,
okay.
I think if I saw this right, like it's somewhat like trying to take some of the architecture of language models to actually better understand action.
Okay.
Like and I thought this was interesting as it relates to some of the invasive implant work that's going on, in terms of, if you're recording from cortex, what what should the neural representation look like, if you will?
Yeah.
Right.
Right.
And so the Neuralink co-founder who was at this Foresight meeting was talking about having electrodes in motor cortex, and to some degree having joint angles as representations. And I thought that was interesting. Again, like thinking somewhat about the forward model of this, so to speak, is like how to program robots.
Yeah.
And it's interesting when you look at some of these these robots that say build cars or things like that, like the representations that the programmers start to use aren't as clear as take a little learning to get the right frame of reference, and what you're actually asking different parts to do. And I thought this was an interesting kind of redescription of action problems with this kind of large language model vocabulary.
Okay.
Yeah. And that could be that might be useful as well.
Yeah.
I mean, like one, so much optimization is going into like, how do we, do that better, do that, bigger.
Yeah.
but also, yeah, like would this redescription actually help us in terms of rethinking the neural representations?
Right. So you have this training pipeline, and they're using that to like they're using it for LLMs, but they're also kind of transferring it to action sequences. Yeah. Because there is this connection between action and language, like language and motor control.
I mean, you think about a sentence as being, a complex action,
Right.
in this, like it's building, each stage is building something that requires, its completion requires this time horizon, or looking ahead,
Right.
For what you're trying to do, right? And just like these world models.
Right. Yeah, we haven't talked about the world model stuff in a while, but well, like last week or something. But
but these complex actions, and I think this is why they would say that tool use is so important for next gen agent modeling, or agent training, is that when you think about using a tool, again, like get robots building a car. There's all these sub actions, for complex tool use, as well as these longer term end goals in terms of what you're trying to do with that tool, right?
Yeah.
So and so you can think of it as like the mechanics of playing the piano being different than the kind of the piece of music you're trying to play, but
Right.
but both require that same expanded, to use the Levin cognitive light cone, or
Yeah.
but certainly, like, you need to think out multiple actions ahead.
Right. Yeah, that's great. So let's see. There's this paper, this talk on YouTube, Jack Van Horn, phenomes, connectomes, and genomes.
And just always good in psychiatry to follow the autism research, because as I always say, autism was really important in changing psychiatry's focus on verbal self-report, where it's like, if you're dealing with kids of an age where they don't talk yet, or language is delayed, you've got to start using other markers to get at what's going on, and even better if those are physiological. So it was a nice overview. He runs a great biomedical data science institute at University of Virginia, but that is that I follow, and he does weekly meetings online for that. But it was interesting to see him present his work. And again, it has a brain imaging focus. So
Yeah.
it played to, I'm biased on this.
Brain morphometry.
Yeah.
So this one was really interesting when I saw it. The neural erosion emulating controlled neurodegeneration and aging in AI systems. This is a number of authors here. Yes, this is again.
No, these guys.
Was that?
I don't know them.
Okay. So they're again using large language models. So this is creating controlled methods to simulate neurodegeneration. So this is where we have this sort of, I guess, reverse plasticity is one way to think about it, but it's usually something that's associated with aging, where you're you have suffered deficits in behavior and in neural processing, due to age, due to atrophy and things like that. So they're trying to simulate neurodegeneration and create a controlled way to do that. So sort of to match what happens during aging. And then this is, this allows us to look at brain function decline and cognitive disorders. So they use IQ tests performed by large language models, especially Llama 2, which is the model that they use to introduce the concept of neural erosion. So this is something they're coming up with here. This deliberate erosion involves ablating synapses or neurons. So you have a neural network where, some sort of connectome, and you take out synapses or neurons from that model, and you remove them, and you see what the effects are. So it's a sort of knockout experiment, but in a computational sense. Or adding Gaussian noise during or after training. So this is just obscuring what was learned. So it kind of mimics, some sort of deficit in learning where you can't separate the signal from the noise. That's especially important for sensory learning, where you're getting like auditory information or visual information, and there's a noise involved, so you can't detect the actual signal. So this is a psychophysical sort of thing. So you can use either of those approaches, and this results in a controlled progressive decline in the large language model's performance. So they're using a large language model for this, Llama 2. They're applying these two different techniques. They're seeing a decline in the performance on these IQ tests. And I don't know how you perform an IQ test in a large language model, but at least it's something that you can use as a benchmark, and you can if you make these interventions, you can see an effect. We were able to describe the neurodegeneration in the IQ tests and show that the LLMs first loses its mathematical abilities, then its linguistic abilities. So you can actually ablate things. I don't know what they're using for synapses and neurons, maybe just the underlying network. But they're able to show this loss in different type domain-specific abilities. And so but it doesn't lose ability to understand the questions. To the best of our knowledge, this is the first work that models neurodegeneration with text data compared to other works that operate in the computer vision domain. Finally, we draw similarities between our study and cognitive decline clinical studies. We find that the application of neurodegenerative methods, with the application of those methods, large language models lose abstract thinking abilities, followed by mathematical degradation, and ultimately a loss in linguistic ability, responding to prompts incoherently. So this is just so happens in humans. Humans will lose abstract thinking first, and then their mathematical abilities, and then their linguistic abilities.
Yeah. Well, and you can see this it's even early changes in sentence complexity can be leading indicators of cognitive decline.
Yeah.
So I think they were trying to get at that aspect of how people look at this in terms of trying to find these early indicators of cognitive impairment. And match them to language models. So it's definitely interesting. I don't want people to start using language models as surrogate humans yet.
Yeah, I'm a little skeptical about that.
Yeah. I get I get that criticism.
Right.
It would be, again, can't, when you can say something much more specific about, how language is structured and how it's structured in the brain, and, and how this perhaps explains like frontotemporal dementia in what its targets are in the brain, and relate that to the underlying model in some clearer fashion, like that would be much happier.
Yeah. So I mean, yeah, when the way they have like this progressive loss of ability, I wonder if it's like it says more about the abilities and the way they're structured than the actual like brain. So
yeah, but for sure, and it's like, the large language models are picking up something of I don't know what to call it. Like the way our knowledge graph is built. Perhaps like it's I forget what somebody called it, like it's like a fuzzy retrieval system, or off of this huge corpus of data that's been trained on, right?
Yeah.
And but again, like it's you don't want to encourage this, like, oh, we don't need to study humans anymore.
Well, yeah, and that's that. I think that's something I would really like to, like, I don't know, attach onto as sort of this weird phenomenon of like I think there's stuff, and hopefully I'll learn more about this summer, ha ha ha. But like in the diverse intelligence space that would address what I'm trying to say really well. I just don't know what it is yet, but I want to get at something like there's very specific reasons why what appears to be conscious to us as human beings and how we've made LLMs to work. Like there's something there about that. If you put LLM in front of other intelligent things, they may not feel the same way. Obviously you can be like, oh well, we can generate story video that will entertain the cat to look like a butterfly to chase around. Yes, but also like there's sort of a very specific sort of anthropomorphic or anthro-egocentric stuff that's at play, and I think I don't like how it's always brought up, but like some of the merits of the cognitive science crowd, who is perhaps, but it's particularly interesting because like the cognitive science are like 100% computation is cognition is consciousness, and you have, well, maybe not folks, and so it's you have that arena of no, cognition and consciousness is this biologically unique thing, which I'm not saying it isn't, but it's also like where there's some merit, there's some very deep merit. I don't know, that's a word. There's a deep substance to me that I want to flesh out. That's like why, and it keeps going. It weirdly keeps for me going back to the paper that I didn't write on analogies about what the brain is. I think I need to just do that paper. Like it was like part of it was supposed to be a historical survey on like in essence the brain or the mind. I don't even say mind is maybe a better word here because mind is well, the looser term, I suppose. But just like it's supposed to be a historical survey of that, but it's also related to like what's a technologically complicated thing that you understand somewhat instrumentationally that you know about that exists in your current culture, and you can liken it to that. And like there's something about that, and then also something I've tried to I did not articulate very well Thursday night, but it basically is something about how not just a retreat into it's so different semantic disagreements. I don't want to go that far, but sort of like trying to parse out with Yogi's argument, like what outside of I tried to say earlier, like I give credit a certain kind of credit to the polemic. I'm going to say all the pins like pin computationalists, they're all wrong, and here's why, because you can't reduce it this way. Sure, but I think there's something to trying to tease out what is like what's really going on outside of sort of the word stuff, like getting past the word stuff there. And so there's something similar between that and what I'm trying to talk about with what Morgan's bringing up here, which is that yes, let's be careful about saying like there's silly reasons why we shouldn't say an LLM is exactly like a human, because there's sort of this very weird like egregious overlooking of the fact that we've designed it to communicate with ourselves, and we're basically offloading all of the thus far inherently biological stuff that has to, you know, undermine or support, not undermine, but undergird everything else. You know, like there's a reason why that's the case, but also like understanding, I guess, sort of a humility around that process and why it matters, while at the same time realizing, yes, you know, there's an importance to examining what are the LLMs doing? Are they doing I forget the term that Morgan used, but like, what are they doing in that space that's actually like the thing, and not just saying, oh, that's consciousness necessarily.
Right.
That's tracking something.
It was interesting. Machine Learning Street Talk has several videos this week that are all good. But one was with Chris Bishop, you know, who's the Microsoft researcher, and I think was their head of data science or something for some time. Anyway, he's got a new machine learning textbook, but he was talking about students taking tests. He's super impressed by the language model accomplishments at this point, and was saying that, like, when I have a student that, you know, gets like 95% on the test, I don't say, you know, you're a very good stochastic parent. You know, I you know, give him accolades for becoming a you know, accomplished, you know, mathematician, or whatever the test was on, you know, and yeah, it is at least forcing us to have to be a lot more clear about what it is that is.
Oh,
no, sorry, it popped up very quick.
oh, does he comment about a student
Wielding.
also wielding large language models?
Yeah, he didn't. You know, or I've watched about half of it. No, you know, and I, you know, with things like Brain GPT, I think there's obviously some interesting, you know, augmentation possibilities with large language models, and I don't know if they got into that too much.
Yeah.
I can totally imagine that there's so many other things you'd want to talk to Chris Bishop about.
Yeah.
But you know, so one, it's like, how are we not stochastic parents ourselves? You know, and to some degree, you know, our 10,000 hours of training as just being, you know, exposing ourselves to enough material that we can somewhat, spit it back out.
Yeah. Depends on the structure of the test, right? It's like if it's a
well, there's you know, and you know, it's funny because at this Foresight meeting they were talking about, you know, like these benchmarks just keep getting knocked down, you know, all this progress, and I was like, I'm pretty sure, you know, I haven't checked Chalet's work recently, but I'm pretty sure that like most of the art challenge stuff still stands. You know, not hasn't been knocked down yet.
Yeah.
Anyway, it's you know, there's a lot of structure in these models that is interesting, as long as we don't lose sight of the fact that, you know, it's just a big neural network.
Yeah.
And yeah, that we need more data collection is what I'm trying to say from humans for solving problems.
Oh yeah,
especially in neurodegeneration.
Yeah, you know, there's some insights from like animal models here. So animal models, of course, we use them like rats and even C. elegans to model, whatever disease we're looking at. So, and one of the reasons we do that is because sometimes we can find analogs. So people study birds, they look at the language circuit, and there are parallels between the bird song circuit and the human language circuit. And it's not a one-to-one mapping, but you can, if you knock out certain parts, you can produce deficits in the production of the vocalization. And so that's something that we say in science, that's a good analog, right? So it's not like we're actually probing the thing, but we're getting an analog and seeing maybe what genes are involved or what structures, if you do certain things to them, what happens. So there are all these things that we can learn from models that aren't like exactly like humans, but it's kind of like, okay, well, we can take analogs from that. And so it's interesting how, and some people argue, animal models are maybe not a great way to go. I mean, if you learn something in an animal model, what are you really learning about the human behavior? And so, but the NIH, of course, funds a lot of animal model research. So it's, it's there and we can learn, and we have learned from it, right?
Well, it's also that there's a lot of work that there's a lot of research work that we're doing that we wouldn't do on humans.
Right, exactly. Yeah.
And but I mean, it's a good point though, right? And so like looking at this 40 hertz entrainment and how this is potentially improving, what are considered one-way neurodegeneration pathways, right? There's a good, or I'm looking at the mouse model for that in terms of the genetic model and its protein accumulation and et cetera. But I saw a headline. I should have posted this paper just because the headline was so ridiculous. But it was just like mouse model schizophrenia shows new dramatic treatment or something like that.
And then because it translates.
Like in what way is this schizophrenia? And in like to the stochastic parrot kind of problem, like how would we even know?
Right.
Like if we have so few biomarkers of it, it's much easier to talk about the molecular biology of Alzheimer's than the molecular biology of schizophrenia, right? Which is more intertwined with disordered cognition and disordered and as Guillaume Dumas shows, like disordered social cognition.
Right.
Anyway,
so it's like the stochastic rat. Yes.
There's lots of I'm seeing so many great links that we haven't talked about in this.
Yeah.
So
let's go back to that. We gotta move a little bit faster, through these, but we have.
But this Nicole Rust discussion was awesome. Or like they had six people, all really interesting and somewhat getting at the this discussion of about schizophrenia, like is it a brain disease? If we're talking about disordered cognition, like at what point is it? It's not like not a brain disease, but like a disordered weighting.
Right. Yeah, that's good. This isn't. Yeah, I guess this is neuroscience and philosophy salon. Okay. Let's see. Exploring the interface of metabolic and mental illness. So this is someone who's working on
that was actually someone that Amanda, I think, had recommended.
Okay.
So I think she had posted something in Cognition Futures or related channel about understanding mental illness as neuroengenics or mitochondrial disorder or similar kinds of. It was some unifying theory of mental disorders,
Right.
that related to metabolism. Yeah.
This is bringing precision therapy to mental disorders. Oh, this is the YouTube channel here. Okay.
Yes. Oh, okay. I did point. Yeah. So, sorry. Bringing the precision. Yeah. So that was the scripts. Yeah, that was the scripts talk, which was good. He definitely had, this. Given the institute, there was a lot of. It was more this kind of like oncology view of precision medicine, right? Where it's just like you're a good understanding of the genomics as it relates to this individual across multiple alleles. It definitely had some particular therapies and some particular disorders in mind. That was interesting, But I want to set that up versus Danilo Bozduk, who's talked at the Brain Space Initiative, who's the Mila researcher in psychiatry, and trying to emphasize the neuroimaging as the kind of physiological measures, not just genomics, that we can get to help identify subtypes and identify potential therapies of interest. But yeah.
And then so we go from precision therapy to mental disorders to our mental disorders, brain disorders. And this is what we were talking about with Nicole Rust and other people here in this YouTube video. There's this stuff on gaming, putting the gaming experience at the center of therapy, the video game therapy trademark approach. And so this talks about this. I guess this is a specific platform for this. This is talking about video games, the video game therapy approach, where game experience is put at the center of the therapy in a tailored way, connecting the individual patient's personality, the therapy goals, and the suggested type of video game through the Myers-Briggs type indicator, which is the MBTI. And then a VGT score assumption is that playing video games facilitate patients in reaching conditions where traditional methodologies and therapeutic approaches can work best. And so this is going through this. This is their copyrighted platform. So, and then, it currently is in 3 association of positive results in promoting emotional experimentation and literacy, social feeling, sense of identity, and activating cognitive processes. So these are the sort of the powers of the VGT approach. This is, so I don't know, let's see, Jesse had something to say about that, because I know it's kind of his area.
Right.
Well, no, I mean, I had a comment about other stuff that I'll address later with just like being a student now. I didn't get to, I just saw the paper with the MBTI stuff, and I'm curious about that. I didn't even hear all of what you said, but I'm trying to, in Slack, which one is it?
This one here.
No.
Putting the gaming experience at the center of the therapy, the video game therapy approach.
And, again, kind of coming out of Adam Ghazali's lab, and Akili Interactive, I've seen a lot of these kind of digital health approaches where, again, it's somewhat related to computational psychiatry in the sense that you're using the kind of complex behaviors that come out of gaming to subtype people, right? And as well as using in-game metrics to show some sort of progress, potentially, right?
I think Go ahead.
No, go.
I'm just looking at this now because this will be something like this is very much like Avery and past stuff. But Aldarian therapy, yeah. So let me see. Individual patients' personality therapy goals. Yeah, I think that's good. I honestly think I wish MBTI wasn't so popular because I think it's basically trash. But like, it's the name. If you're gonna have to start, you're gonna have to reference that, which is annoying. Like, even the Big Five is sort of nicer in a way, but there's what I would love to do. Full disclosure, I would like to do something similar to this with different theories at play, including some that Avery's been cooking up. Like, that's full stop. What I would legitimately do that. Like, no qualifications to that. I would totally do that, and that's something I actually would. Part of the ABM work I'd like to do is a bit in that direction also. But for this, like, I think the best use of personality, best use of like personality theories is to offer tailored, useful space for not convergent but divergent, not necessarily neurodivergent, but just divergent takes on things. Like, my biggest thing I take away, even though I spent many years in the pseudoscientific space of personality theories and personality type and a lot of BS stuff, but like one thing I think is very poorly grasped by everything that I've ever put into the person studies category in psychology, cognitive science. Like, there's really bad. Like, there's a painful monolithic nature to saying, oh well, the human mind is going to do blank. And do I think, well, actually, the best way to think about it is with MBTI types? No, I don't. But I think there's a tension between a much broader necessity of nuance. And so using this as sort of a platform to do it in a way where we're using a theory to further explicate what I think are painfully obvious and underrepresented differences in just even neurotypical people just having different personality types and information processing styles. I think is like absolutely. I think in enough time, people will be wondering very clearly, what have you guys been doing? Like there's a certain massive absurdity to the lack of that being addressed properly. So I think this is an avenue for doing it. That's why I'm interested in it. So I'll get off the soapbox.
No, absolutely, right. And I think again, when posting a link on Slack, it is not an endorsement.
Yeah.
Yes. and I think it's. I love this paper because it's using this registered trademark, which I think says a lot about the people who did this paper.
Yes.
And so, I'm like, you go right ahead and build on, Myers-Briggs.
Yeah, I was gonna say.
Well, but I think, but
I just again, like I want us to push on and hopefully get to Daniela Bostock, who again wants to really, he's trying to say how important it is that we change our analysis to allow for diversity. And how important that so it's like and the Mila and Montreal people in general get that like we don't know what we're doing yet, right? We need to be doing open science. Nothing's ready for monetization.
Right.
We need more eyes on this. We need more data. And we need to broaden the way we approach the categorization.
Yeah. So I wanted to, maybe do two more things here in the channel. Let's see. So this one is embracing cancer complexity
Yeah, yeah.
Hallmarks
So
of systematic disease or systemic disease.
yeah, and so this just got at my, what has been really great in terms of engaging with the biotech and um, um, biomanufacturing community, is that understanding that oncology has been leading the way in this kind of um, molecular cellular understanding as it relates to system dynamics. Like it's the area to learn from, and so partly, certainly in the biotech scene, like, of course, there's a lot of people who see a lot of, pots of gold at the end of the rainbow. Uh, um, but it's, again, these are understandable mechanistic models that people are trying to, develop, and they're putting together so many of these pieces into greater and greater systems that that I think is just really important for psychiatry to be trying to model for as long as possible. Yes, we don't think it's ready either, or not necessarily useful.
Yeah.
Yeah. It's again, my posting paper is not an endorsement.
Right.
uh, I mean, we've talked a lot about this in terms of again, like how to focus funding, and a lot of digital health gets funding in psychiatry over pushing what this kind of trying to understand molecular and cellular differences in psychiatric disorders. Whereas I think it's like much more interesting to focus on the new blood and other biomarkers that we are now capable of measuring in individuals. I'd love to see more focus on that and less focus on let's give psychiatric patients an app.
Yeah.
Just so we're clear.
Yeah, so this is, cancer research, which has also been heavily funded. And so, they've kind of worked out a lot of the measures that you might use for like some specific thing. And but it's important to say here too, is that sometimes you have conditions like in cancer where, you have very clear markers, and other things like in psychiatry where you have behavioral states or conditions that can be less characterized using these kind of things.
Gaming is a great way of getting complex behavior, metrics.
Yeah.
Right. Like that absolutely. And I think there's something to be said for games where people have got to learn a new tool,
right?
And just seeing how they approach that problem. Even better would be games where they have to interact socially with a group and try and get something done.
Right.
Like these are all really interesting ways at collecting data that would be perhaps more informative than verbal self-report.
Yeah.
Yes. Which has been the traditional psychiatric diagnostic information.
I think that's the whole, like, all of the stuff we're looking at for phenomenology, right? And my whole shared cognitive environments we robot poster, which is a very vague gesture, because how do we get some kind of meaningful difference with an actual uniform testable environment that has all the fun computational stuff that we can control and get the data from the interaction with the inherently computational environment that we want to do all our science stuff with. Yeah. But having exactly what you said, having a space where there's meaningful interactions and meaningful differences, so not just forcing you down there's a one. I heard this in another place recently. It's really good. Not just forcing you down to one path of victory or one path of cognitively operating, but being there a diverse enough space to show the actual potential.
Yeah. And we need more of those, like you see in autism research. We need more of these alternate methods at getting expressive, interactivity and interaction and expression from the person. Like we need to find where they have their best voice,
Yes.
And it doesn't have to be verbal self-report, and it doesn't have to be sharing negative thoughts and again, I've been really enjoying the comedian Maria Bamford talking about her own mental illness. I mean, one, I just love that her book is titled "Sure, I'll Join Your Cult."
Yeah.
But as a great example of someone who has shared things with her psychiatrist, and then that psychiatrist is called the police. Like I'm not saying that, but there's just so many. There's such diversity in terms of those states, like why people would be holding back, and can you find alternate arenas for action and metrics that would be important, revealing, and help subtyping.
Yeah. So Jesse has a comment here, just basically says, yes, we also need better theories, and if we have better theories, then we can actually, have better models. And a lot of the video game stuff too, there are a lot of physiological measures, psychophysiological measures you can pick up during the gameplay, so you can figure out kind of what people are engaging and where, right?
Yeah. And I was super lucky as an undergrad. Hussein's not here. That my advisor in psychology was doing gaming. Was basically making video games where the person didn't know this, but they were going to fail. And like her whole point was actually how do adolescents cope with failure?
Right.
So she's got like, hey, you want to spend time playing video games? Kids are like, oh yeah. And then just when they think they're going to win, they lose.
Right.
And it was really about generating that internal struggle.
Yeah.
And seeing those physiological changes, seeing the and the behavioral cognitive problems that came in the aftermath of that. Super interesting, and that was back in the 90s.
Yeah, it's like the Kobayashi Maru for psychology research.
Right. No, exactly, right.
Yeah.
Anyway, so she's still got a lab, but she's now like vice chancellor at Purdue.
Yeah.
So I don't think she does that as much, but I still think of those studies all the time. Yeah.
Yeah. So like one more.
I hadn't thought about the Star Trek connection.
Oh yeah. One more point on the cancer complexity thing, and it's like we talk about cancer as being a success story for like all these physiological measures and being able to sort of figure out. But the problem is, of course, cancer also is a phenotype that is hard to sort of diagnose. Like we know certain cancers are we know very clearly some of the diagnostics. But like their behavior is somewhat of a mystery even today. Even the better characterized ones, we don't know when things are going to go into remission or come back and spread very fast. So we can do things to treat certain types of cancers, other types of cancers not so much. And so maybe it's a good analog to psychiatry more than we'd like to admit, because it's not just the successes but the failures as well. Yeah.
Absolutely, absolutely, and we don't talk about we didn't talk about this paper, but like one of the papers we skipped over was just about the homeostatic problem. I forget what it was, but it was like controlling a salt solution. Or sorry, I don't know if I'll be able to. Just gonna keep going. Yeah, it's definitely up a bit more. Now keep going, keep going, keep going.
Yep.
Right before that,
this
no,
one.
down. I think, yeah, brine space. Yeah,
Brine space.
Gradient,
Okay, yes.
gradient descending through brine space.
Yes.
Yeah, it was salt. Yeah, so it was just a really interesting problem about, you know, something you'd think is a simple homeostatic mechanism, right?
Yeah.
And I don't know. I think too often we have this thermostat model in our mind, and not, you know, kind of like how many ongoing physiological processes that the body is monitoring, and how they potentially, you know, relate and things like that. But when I'm just thinking about, you know, when you just see the kind of complexities that come into this particular problem,
Yeah.
and then you think about trying to do psychiatric dosage, right?
Yeah.
It's like, well, of course we're doing this, you know, basically trial and error, you know, and you know, part of the monitoring of these patients over months is being worried about getting that combination wrong, and kind of losing the patient,
Right.
you know, and which is, you know, and in severe cases is why hospitalization is recommended while you're doing medication, you know, trials and dosage corrections. Right?
Yeah. So this is
Anyway.
Yeah.
Yeah.
They say for esoteric biology reasons, sodium can only be absorbed in the gut when it's paired with glucose, and so this is a treatment for cholera where they have, you know, they were trying to figure out a treatment, oral rehydration, and they had to create a solution, and they, you know, it was, they didn't really know how to do it, and they had to do it in this way that they describe in the story. And you know, it actually reminds me of some of the stuff we've been looking at in the cybernetics reading group with respect to Rosen's MR systems, and some of the stuff that we talked about with these diagrams, where they have these sort of continual feedback loops, uh, these spiral things that we were looking at. And I know if you're not in the group, you don't know what I'm talking about, but they had these models where they drew out the spiral. So like, you know, instead of having causality from one thing to another, it would be circular, and it would just keep going through time. And so this is kind of what we're talking about here.
Yeah, I mean, you know, I was thinking about what was the Chilean thing, CyberSyn?
Yeah, CyberSyn.
Yeah, but basically macroeconomic theory.
Oh
you know? and you know that you've got so many systems where your measures are coupled, you know. You know, and it's you're changing this thing to deal with this problem, but you start creating another problem in a different area. And, you know, because you don't actually know what the governing equations are.
You're right.
Yeah. So, and that is again a big part of why climate modeling is so hard. Yeah. And again, like, it's important. The climate modeling is not just about it's not the chaos. Is that there are inputs to the system that we aren't modeling.
Right.
that you know, it's not just like random. It's that like there's stuff going on that we're not yet able to track and model properly.
Yeah.
Yeah.
So So to finish up the channel, I have this diagram I found. It was Nicholas Fabiano. And it says, this is a map of repetition among all symptoms of the DSM-5. And so this is the image here where we have, just these different things in the DSM, these different categories as we talked about them, and then how the symptoms repeat. So the idea is you create this typology where you have symptoms, they're defined by symptoms. And, the symptoms can be overlapping, so you don't go back and you say, oh yeah, well that symptom can only be this thing and not this other thing. The symptoms can be multiple things. And then, when you diagnose someone, you have to kind of figure out, the process of elimination, what the actual diagnosis is. And so then this actually goes through, uses network theory to say, if we build this circular graph, from all these nodes, we can look at the different symptoms and say which two diagnoses are connected because they share symptoms. And so you can see here that it has this really interesting graph topology where you have a lot of, what in these circular graphs, basically, if you see an arc like this, a line between two parts, these two nodes are connected. And you usually will see them like if the nearest, I don't know if they're ordered in any way, but you'll see these patterns of connectivity. So a lot of times, like things will be connected to like things, obviously, but you can discover like different categories of things if you look at sort of these little modules that form. So you have this group of connections here, a group of connections here, and there are statistical ways to sort of treat this more rigorously to find like groups or communities or modules. But this is an interesting graph because it does reveal maybe what kinds of things are linked, or at least what categories share symptoms. And so I think that's a really interesting graph.
Yeah, and it reminds me a lot of the graphs that were put together, genomic graphs put together across, bipolar, schizophrenia, and autism. That there being, being multiple risk factor disorders, and this kind of shared genomic risk in this same kind of way,
right?
And and then to take that another step, and again, this somewhat relates to the kind of cancer landscape approach, is the genomic overlap in autism, epilepsy, and gastrointestinal disorders.
Yeah.
And again, I think really revealing how neurodevelopment is central to all this, and kind of these changes in genomic profiles over time, and the complexity of spatial morphogenesis, and how it relates to your genomic profile at any particular time point.
Yeah.
Right. And yeah. So it's more of this would be great.
Yeah. Yeah, I did want to move on to reading, but yeah, all right. So yeah, Jesse explained what Kobayashi Maru was. I made a comment.
Okay.
Yeah, so that was good. And I think Vrushali was here, but she left. I don't know, but yeah, welcome.
I did see. I saw. Yeah.
So, anyways, yeah, let me go to the paper I was going to talk about. So we've been talking about things, with computational approaches and pan-computationalism. And there's this critique of pan-computationalism that algorithmic approaches aren't enough. So algorithmic approaches are basically where you say, I can design an algorithm to replicate the mind or a biological system. And so, when we think of algorithmic approaches, what we're really thinking about is like the output of an algorithm, or what can an algorithm express. So there's this area of research called expressivity, and this is a part of computer science where you look at, just trying to figure out if I can spell it, there we go. And it's the study of, like, if you look at an algorithm, you look at its outputs, what is it able to represent? What is it able to output? Can it output every state in a system? Can it output maybe a limited set of states or whatever? So if you look at a lot of algorithms, you can usually build some sort of tree which produces outputs, sort of classifying the outputs of whatever it is that you're doing. So if it's like a sorting algorithm, your outputs are like sorting these things into categories. They could be hierarchical. You could have a binary tree like this. You could have other types of structures like, lattices or graphs that, produce outputs that, but the point of this is that not a lot of algorithms aren't fully expressive of the kind of system they're trying to model. So, they're not necessarily expressive of the full range of variation we see in the brain or in biology. These aren't mutually exclusive, but you get my point, or like cognition. And so when you develop an algorithm for, say, like cognition or biology, you're limited in what the expressivity of that algorithm is. So this is maybe like a sorting algorithm tree. This is a binary tree, and then there are other kinds of data structures that other types of algorithms can produce, but none of them really produce this full range of behaviors. Now, there's something called Turing completeness, and I'm not going to get into that today, but there's this idea that we can create a symbolic system that is complete, that will allow you to build like this full set of representational states. So it has like the ability to be fully expressive. And so, basically when you have an algorithm, you have symbols, a set of symbols, and they can recombine, or they can have some sort of relationship between them and another that give you this output. And so there's this combinatorial aspect, but again, you have to have the proper symbols in the system to start with. So Turing completeness is seen as maybe something that if you have a computational system that's Turing complete, you should, in theory, be able to simulate a lot of the states in something like biology or cognition. If your algorithm is a high expressivity, you're in good shape in terms of trying to approximate biology or cognition, and so forth. So we're dealing with algorithms, and we're dealing with the limitations of algorithms, and this is really where we talked about this a little bit Thursday with respect to the Avita platform, and how the people in the paper we were reading, the relevance realization paper, made the argument that any algorithm that you make for something like biology or cognition will be incomplete. And so that pan-computationalist view that computation can really get at the structure of biology or cognition is incomplete, and that's a false type of approach. And, we should abandon it in favor of something else. And so this is where this is the sort of what I'm setting up here for this paper, which is actually in the ACM communications. I think it's from just recently. It says Angel Goni-Moreno, who's from Barcelona. He works in the group there. They do a lot of complexity stuff. So they've been doing stuff like this for a long time, working in these areas. And this is titled Biocomputation, Moving Beyond Turing with Living Cellular Computers. So they're kind of saying that, we're not, there's this aspect of sort of the Turing machine or the Turing approach to computation, then maybe we can go beyond that and find out, kind of think more in terms of living systems. So it's a different view than what we talked about on Thursday. This is actually, I think, maybe quite a unique view, because I don't think they talk about throwing out computation per se. It's just throwing out our conventional model of computation. So it is a well-known story that theoretical computer science and biology have been drawing inspiration from each other for decades. While computer science has tried to mimic the functioning of living systems to develop computing models, including automata, artificial neural networks, and evolutionary algorithms, biology has been used biology has used computing as a metaphor to explain the functioning of living systems. So Jacques Monod, who's a famous microbiologist, he wrote the inspirational statement, like the workings of computers. And he used, famously, he used Boolean logic to conceptualize gene regulation, and he used this for, studying expression circuits in microbes. And so he was able to build these kind of models that are predictive. So this is, this is not like, it isn't a total waste of time to use computational techniques in biology. It's just that maybe it's incomplete, maybe it's not. That's what we're trying to wrestle with here. This article contends that information processing. So we talk about information processing in cognition. We talk about this in molecular biology. Contends that information processing is the link between computer science and molecular biology. And this is, of course, what we talk about with cognition as well. And there's a link, but then the question is, if we represent information processing in a computer, is it similar to what we find in the natural world? Information and its processing lie at the core of both fields. In computer science, a model of computation, such as finite state machines or Turing machines, define how to generate output from a set of inputs and a set of rules or instructions. So Turing machines look a lot like this little diagram here. It's a little bit more formal with, probabilities on these transitions between states. And so we can kind of figure out, like, we have this Markov model basically of a program where the system moves between states, and we have that information. Now, this is not something that you can isn't relatable necessarily to a biological system. You can model a biological system that way, but to say that a biological system behaves in that way is maybe not, doesn't capture the complete set of behaviors. These types of models define how to generate output from a set of inputs and a set of rules or instructions. So with like Jacques Monod's model of molecular biology, you would have a set of rules for transcription, for expressing a gene, instructions for how that happens. You have a set of inputs, which might be some sort of transcription factor binding. You have an output, which is a gene product. And, we have like stimuli in the environment also as inputs, which can then generate outputs. So this is the Lacazette operon that he is famous for. You have some stimulus, you have this, expression of a gene, and then, you can build a computational model of that, and it describes that particular system well, but other systems maybe not so much. Similarly, biological systems like the bacterial cell in figure 1a, which we'll go down to later, sense and react to input stimuli to generate a response according to their internal configuration. And so this is a point that we've talked about with respect to some of these criticisms in that, they say, well, you can't really model biology as a machine, or you can't really model it as something that's computational. And one thing that is actually kind of a newish area that can maybe shed some light on this or maybe contradict this criticism or blunt this criticism is synthetic biology. So using synthetic biology, it is now possible to modify the specific nature of each of these steps in biological systems. So, you're able to, I know there have been a number of papers, I think the Maturana paper, for example, where he talks about biology and like a cybernetics of biology. And he talks about, this is in the 1970s, so they didn't really have synthetic biology back then. They didn't even really use gene engineering where you're able to express genes very much back then. So they didn't really have that, that set of studies. Well, what we're finding with synthetic biology is it's now possible to modify the specific nature of each of these steps in biological systems. So we can actually create something that computes, but it's a biological system. So there are a lot of synthetic biology circuits that compute like a simple program. It executes a program that prints hello in some sort of enzyme. It expresses an enzyme in the letters hello, and that's like a demo that you can build, and it's not that hard to build. You just use a couple of different types of gene circuits, and you put them together, and you can produce this behavior. So, I mean, you can do with very simple systems like that, with synthetic biology systems, we can build these sorts of computational systems, which complicates this problem even more because, now we just can't say that algorithms are incomplete. We have to say, well, a computational algorithm without the biology might be incomplete. But if we add the biology in, we might have, a different outcome. So we're able to program and probe information processing in this way. So this is an exciting breakthrough, and this answers some of our questions with respect to this. These key insights are interesting. We have cellular computers that could outperform classical computers at specific tasks. There's a concept termed cellular supremacy. Someone's been reading the machine learning literature, the AI literature.
Yeah. That's awesome. I've never heard that before.
The notion that computing is only possible with silicon-based machines is a common misconception. In fact, other implementations are possible using different forms of matter. So you can also program living matter, and people do this a lot in nanotech and in genetic engineering or in synthetic biology.
Yeah.
Where
DNA computing was certainly back in the 90s being proposed.
Yes.
Yeah.
And so there are these whole fields that we can look at and see what people are doing, and they kind of put those kind of questions on their head because you're using a biological system, and it's not really complex. It's not like the human brain, but it's this maybe a multicellular system like slime molds, or you have gene circuits that have a lot of complexity given their size, and so we can do that. Developing cellular computers is not only intellectually interesting, but also has practical applications. So these are, in different areas. Different types of organisms can be effectively manipulated to implement computing functions such as Boolean logic or distributed algorithms. So Boolean logic, of course, you find this in the LAC-Z operon, which is, a very simple circuit. But you can also build new circuits, and people do this with genetic constructs that they can design and build and get them to express certain genes, and that allows you to, you can do this at different dosages. You can also build synthetic circuits themselves that do certain things. You can take like a bacterial cell, and you can take out all the non-essential genes and then reboot it with these engineered circuits, and they can do very specific tasks that they couldn't do in nature. So you can do a lot of things with these kind of approaches, or distributed algorithms. Their DNA is edited to sense inputs and deliver outputs in response to human-defined rules and instructions. And this is like this Levin and Bongard paper that we talked about in I think it was in Cognition Futures or in Cybernetics Reading Group, where the paper was, it was a tough task that they had, but they basically said, there's this movement towards these kind of machines that are integrated with biology, with maybe like the human brain or with biological systems. And so we need to understand those. And they laid out some rules. And again, the paper was, what it was, but they did bring up some really interesting points in it. And this is kind of going in that same direction, saying that, we've had things that have been engineered. Of course, biological systems have evolved, and we're kind of sticking engineering into that. And then what are the consequences of that? We need to think differently about machines, for example, to make sense of this. So it's not enough just to say that this is a type of machine or engineered artifact. It's that there's this fundamentally new thing. So yeah, the figure 1A, I guess, is the thing that they promised, or figure 1. This is programming bacteria to perform living Boolean logic functions. So in A, we see that cells possess the ability to sense a wide range of physiochemical inputs and deliver outputs according to algorithmic rules encoded in DNA. So you have these physiochemical inputs. They come into the cell, they get, transduced into the genome, they have some effect on the cell. Then there are these outputs, so you can actually have bacterial cells that are engineered to process chemicals to transform them to other types of chemicals. And, you might do this for like bioremediation or something. And the algorithm, of course, is the sort of manipulation of the genome in these bacterial cells. And so that's where so they call that an algorithm, and it's basically just modifying an existing gene circuit or creating a gene circuit and booting it into a bacterial cell. So that's one type of computation. The second are these combinatorial Boolean logic functions that can be integrated into a cell's genome. So this is where they show this DNA sequence, and then they show this sort of rule set that they can put in, and you can do this through inserting different stretches of DNA. So you can insert different codons and things that are, that lead to these kind of rules. So if you have different inputs, then there's an output from this gene. If not, then you don't output anything. And that's basically the same thing as if two things are present and bind to the transcription factor start site, then you get some sort of gene product. If not, then you don't get anything. And so you see this in nature, maybe not as cleanly as this, but you can actually design circuits like this. And then C is, in the example shown, simple logic statements are implemented in the bacterial Pseudomonas, and this is a Pseudomonas here, and visualized using fluorescence microscopy. So these are the fluorescent outcomes here, where you have these different bacterial cells, and you have these different fluorescent signals, so GFP and RFP, red fluorescent and green fluorescent protein. And so when they meet a certain logical condition, the fluorescence gets turned on in the cell, and you get a signal. So the green fluorescent protein is turned on if something is true. If something else is true, then red is turned on in this cell. And so you can actually get that reporter to demonstrate when the computation is happening. So, this is real-time monitoring of the rule being implemented in the bacterial cell. So I think that's a good overview of that area, and I think it brings up a lot of questions, and it's definitely relevant to the things we've been talking about in cybernetics reading group and that debate.
It's interesting to imagine. I mean, obviously, this relates to both, synthetic biology and to some degree even more like Ventnor's synthetic cell,
right,
where you can imagine that the genome that you insert into the cell is specifically constructed for computational purposes, as opposed to some sort of environmental adaptation, or I think that's really really interesting, and I'll try and find this one. There's a University Toronto professor, computer science professor, who did something that's like geometric algebra, right?
Okay.
So geometric algebra being this extension of the imaginary numbers to any dimension. Like expanding kind of the basic rules, and then seeing the what complexity comes from the overall structure, right?
Yeah.
Is doing something similar in terms of adding logic, together with basic arithmetic operations.
Yeah.
And it's interesting to think that there could be some of these non-standard, axiomatic sets that would actually be of great interest to biocomputing.
Yeah.
It's just another. It made me think of that.
Yeah.
It's like Eric Heckner or something like that. I'll find the name.
All right. That sounds great. Yeah, that'd be great.
Super interesting.
Yeah.
And so this was from Barcelona?
Yeah, this group in Barcelona, they do
working with Soleil?
Yeah, Recursole. Yeah.
Okay. Yeah. I mean, he's been doing a lot of, cancer physiology, cellular complexity work as well. That is like really super interesting and real math grounded. Yeah, that's awesome.
They also have this course online that does a lot of this stuff.
Yeah.
So they have, it's not very well done. So that's good on YouTube.
Yeah, that's awesome.
Yeah.
Mm-hmm.
All right. So I think that's it for today. Any other questions or comments before we go?
I'm just glad for the paper, and I'll finish writing up some things for next time. The Google Summer Code's almost here too. Everything's in bloom now, it seems.
Yeah.
But looking forward to continuing all these lines of discussion. But yeah, thanks.
Sounds great. All right. Thank you.
Yeah,
See you next week. Bye.
Take care.
Take care. Bye.